Ovation is a revolutionary tool for managing research data. Ovation makes it easy to organize, search, and collaborate like never before. Researchers already have enough tools and steps in their workflow. Instead of adding another tool to this overload, we've integrated Ovation directly with the tools that researchers already use. Today I'm going to show you how we've made Ovation's powerful features available directly to Matlab users. The experience would be similar for Python and R users as well. In this example, a colleague has noticed a particularly interesting measurement in their data set. They would like me to take a look. I'll start by creating a connection or data context to an Ovation database and entering my username and password. It is now easy for me to retrieve the particular epoch or trial object that my colleague was interested in using the link they sent me from email. I can retrieve the particular measurement that they said was interesting, in this case a body length or anatomical measurement, from the subject, which was a fish. The value of the measurement is shown here, and I could also retrieve the units, the shape, and the type of data. I may be interested in seeing all the other data from this same genus of this subject. Instead of emailing my colleague and asking them for further information, I can just browse through the connections present in the Ovation database. In this dataset, sources, or subjects of measurements, are represented in a hierarchy containing fish at the bottom, their species, and then their genus. So retrieving the object representing the genus of the subject of this measurement is as easy as asking for that source object. I can now display this genus name and all other epoch groups that contain data from this same genus. You can see here the genus name and the list of epoch groups containing data. Perhaps I'd like to expand my analysis and compare body length and brain mass across all fish in the database. This example begins with a query which retrieves an iterator of epoch groups or trial blocks containing epochs from those fish. The code will iterate through that list of epoch groups, retrieving the body length and brain mass measurements from all of the epochs, and then finally plotting the result. This example lets me demonstrate our graphical query editor for Ovation. In this example, I'm going to choose to find epoch groups with only a single search term, label equal to anatomy. Well, Ovation performs this result and collects the results, then we'll be able to see this plot of brain mass versus body length for all fish in this example database. If I want to add an analysis record which links that data that we just analyzed to the final result, I just need a single line of code. We insert an analysis record here with the name brain length versus body mass, an iterator over the result set of that query, a link to the code that performs the analysis, any parameters, and finally, a link to the source control system and revision number of the code that performed that analysis. This single line of code would create an analysis record in the Ovation database, linking the data, the code, its parameters, and the final analytical result, providing complete provenance and visibility from raw data to final result. I could, of course, send a link to this analysis record back to my colleague for them to view. To send a link to this analysis record to my colleague, I can simply request the URI from the analysis record object and paste the resulting link into an email. I hope you've enjoyed this demonstration of the Ovation Scientific Data Management System. If you'd like more information, please find us on the web at physionconsulting.com or send us an email at info@physionconsulting.com.